Hello and welcome to MicroLive. Today we'll be looking at the drawbacks of modern flat screen technology and the latest research into the flat screen of the future.
And I'm going down to a garden centre where a computer will tell you the name of the plant that grows in the right colour, to the right height and in the right soil for your garden.
While in the States, Fref will be looking at how computers can imitate nature.
Most calculators, digital watches and portable computers use liquid crystal displays, LCDs for short. Now, these were actually a British invention at the University of Hull in the 1930s, but typically we failed to exploit the technology. Last week, though, at the Which Computer Show, we saw a number of new screens. There's a backlit LCD display here from Sharp, and what's called a plasma display from Toshiba. Now this one uses a crisscross of wires and a gas which is lit up as a voltage is applied across those wires. It's very attractive, but it uses a lot of energy, so it has to be mains powered. And just like a television screen, the whole image has to be redrawn or refreshed many times every second. And that incidentally accounts for the flicker that our cameras are picking up. Most screens do have disadvantages. Flicker, for instance, is thought by some to be responsible for much fatigue or eye strain. What we really need is a large but compact, cheap, radiation-free, flicker-free, high-contrast screen which we can easily carry around and which uses hardly any power. Well, on the trail a few weeks ago, Mac went to visit the research and development laboratories of the British company Standard Telephones and Cables, just north of London.
A new computer display screen is being developed here at the STL Labs in Harlow, which has significant advantages over the liquid crystal display screens available on current commercial computers. This Data General computer has one of the largest flat screens available today, and it's not all that popular. It has several disadvantages. Firstly, you have to view it at a rather narrow angle. If you move your head, the image can completely disappear. The contrast isn't all that high. And if you switch off the machine, the information disappears. Here, on the other hand, is a working prototype of the new thin flat screen they've developed. It's almost as good as looking at printing on a sheet of paper. The contrast and definition are so good. I can actually view it from any angle, and there's no fall-off in definition whatsoever. Perhaps even more importantly, this little example was connected 3 years ago, and the image is still there and readable. This display requires no refresh. Let's look at how this actually works. We've made a model of the display here with these two sheets of glass, and these are parallel lines of electrically conducting material photographically deposited on the surface of each of the plates. The surface of the plates in the real thing don't have to be optically perfect at all, and so ordinary glass can be used. The real problem was to keep the glass just 11 microns apart. That's about a quarter of the thickness of a human hair. And the solution turned out to be quite simple. They used small pieces of glass fibre threads thrown at random across the surface. We've represented them here by these small pieces of glass tube. The two plates are laid on top of one another like this, and the space in between the two plates is filled with a thick, viscous liquid. Where the lines cross, just like that, that square is in fact 1 pixel. And we can see this on the real thing by looking at it through the microscope. And you can see the real pixels there, and a few bits of the glass fibre. The real secret of the screen lies in this bottle. This is a very particular fluid that's been developed in this lab with very particular properties. A few drops of this is all that's needed to fill a normal-sized screen. When the molecules are lying at random, the light is scattered. When a high frequency is applied across the liquid, the molecules line up and the light can pass through the pixel. When it's switched off, the molecule stay as they are, and the image remains until a low frequency is passed, when once again the molecules are scattered. This is much simpler than normal liquid crystal displays, which require polarizing filters and an image that has to be constantly regenerated, or as it's known, refreshed. But one problem with this screen is that it needs 200 volts to flip the pixels from one state to the other. The big challenge here comes in providing circuitry that can cope with 200 volts and can connect all the edge connectors from the screen into the computer itself. We can see this on this screen here. On the top here we have 780 connections, down the side 400, giving a total of 1/3 pixels. Well, this makes this extremely expensive to produce, so they've produced a special chip, and you can see them here on this piece of film. When these chips are bonded to the surface, they'll transfer much of the circuitry to the screen itself. enormously reducing the number of external connections which are needed. Once the electronics are miniaturized in this way, the scientists here are confident this screen can be made cheaply, use hardly any power, and end up being very compact. In terms of patenting inventions, the labs here at STC have a good track record. For example, they claim that fiber optics communications were invented here. This is where specially treated glass is drawn out into a thin fiber for use in telecommunications. The glass filaments used in the new screen were a spin-off of this technology. But inventing something is one thing. Turning it into a commercial success is quite another. We seem to be good in Britain at innovating things and completely fail in marketing them. Yeah. Are we going to be able to market this successfully?
Yes, that of course is a very good question. Our view is that we have to manage the exploitation just as well as we manage the research that leads to it. We've got to work out what the current technology can do, where it has a unique position, and so therefore where the customers are going to buy. And that has to be something that's as well managed, if not better managed even, than the research activity that's led to this product.
Are you really convinced this is going to be successful?
Personally, yes. I think this is one of the things that we must make work for Britain, and is a great tribute to the researchers in this laboratory.
What all this means is that we could have a high-resolution, non-flickering, portable, easily read screen the size of a piece of paper, or even larger, and all those cumbersome monitors will become a thing of the past. And there are new applications. How about having an online display for your overhead projector? The resolution's excellent, it's in black and white, but the most exciting thing is that they hope to have a small colour version available for test within the next few months.
And here's a mock-up of the sort of screen they're aiming at. We'll keep you in touch with any developments, particularly on that colour version. Of course, technology doesn't have to be brand new to be applied in an original fashion.